resultant of some non-concurrent forces. So in this case, they're not parallel, they're acting at angles, some of these forces. So now we'll have to do both, calculate the summation of x, summation of y, and then we have to apply the Pythagorean theorem. So we know the y component and the x component. So then the resultant would be simply a square root of fx square fy square. So that is the resultant. So we'll have to do that, and also we'll have to find the theta, which is tan inverse fy by x. So first, and then so we'll find the resultant, and then we'll have to apply the moment principle to find the location of this force. So let's first resolve these forces and find the resultant by resolving forces. So if you resolve this one in x direction, that's going to be 300 cosine 30 degree, and then the y direction would be 300 sine 30 degree. This one we can extend a little bit this way, so that's easier to, so that's 60 degrees. So you can resolve this in this direction. That's going to be 200 cosine 60 degree, and then the vertical component would be 200 sine 60 degree. Now if you do all summation of x's and summation of y, so summation of all x direction forces, that would be 200, that's in the positive direction, cosine 60 degree, plus the 300 cosine 30 degree. So if you add these two components, we'll get 359.81. Summation of y, we'll assume the upward direction positive. So that would be simply then this would be negative 200 sine 60. So negative 200 sine 60 degree. Then this would be positive 300 sine 30 degree. And then this 100 would be negative 100 pounds, simply going downwards. So Fy is total, I calculated 123 point, that is negative 0.21. Now if you calculate the resultant, R is square, that is square root of fx is square plus fy square. So if you put all these numbers here, 123.21 is square plus 359.81 is square, and then square root of that. So that is the R. So the resultant I calculated was 380 approximately pounds, like that. And the theta, that would be tan inverse 123.21. That's the downward direction y force. So let's assume the resultant is acting somewhere here. We don't know exact location. We'll find that using the moment principle. So that is Fy, that is minus 123.21, and then the x direction summation we calculated 359.81, and then the resultant would be approximately in this direction. It's going to be more towards the stronger force. So 539.81. So I calculated it 18.9 is in this negative side here, 18.9 degree. Now, so the location to calculate the location of this force, we'll have to basically calculate the total moments for the component forces with respect to, let's say, this point A. That will be the exact same moment as this resultant force. So if we calculate the moment for the resultant force with respect to A, so summation of moment with respect to A, So that would be the resultant force is this 123 y direction. Now this x component is passing through A, so that's not going to produce any moment. So the resultant 123 force, that will only produce the moment, and that will make a clockwise moment. So that's negative. Not because of this negative sign, because of it will produce a clockwise moment. It will pushing in this direction, this Fy with respect to A. That's why it's negative. Times the distance we are trying to calculate. So that's the d we're trying to calculate. And this should be exact same as all the component moments if we add them. So for the 200 sine 60, this force right here, that is 40 feet away, and that will do a clockwise moment. So that's negative. Then we have this 300 sine 60, that will do a counterclockwise moment, positive. 300 sine 30 degree, and then the distance is 70 feet from point A. So that's 30, that's 40, so total 70. And then we have this 100 pound right here going downward. It will produce a clockwise moment like this with respect to A. That's negative again. So 100 pounds times, and that is total 170 feet from A. So that's the negative moment as well. If you solve for D, I found that 109 feet from point A. So this is this distance, the resultant distance. This is the resultant. So the location of that force would be 109 feet from point A.